Hello, today we're going to look at solving systems of equations by graphing. So a system of equations is just a set of two or more equations that have the same variables in them. The solution to a system of equations is the point where all of the graphs, or if you just have both of the graphs intersect, aka where they cross. We are going to be dealing today with just systems of two lines, or two linear equations. So there's only three things that can happen. The two lines can cross exactly once, which gives you one solution. The two lines can overlap and look like the same line, which is infinitely many solutions. Or the two lines can be parallel, meaning they'll never intersect, which gives you no solution. I have pictures of these scenarios right here. This one is one solution because the two lines cross exactly once. If the two lines cross exactly once, the solution is where they cross, so we write that ordered pair. The point where they cross, the x value is 2 and the y value is 3, so we write that as 2, 3, just like you would any other ordered pair. If when you graph your two lines, they overlap and look like they're the same line, that's infinitely many solutions because those two lines have every point in common. And if that's the case, you don't write an ordered pair, you just write the phrase infinitely many solutions. If your two lines are parallel, they will never intersect. They have no points in common, so there is no solution. Again, we don't write an ordered pair there, we just write the phrase no solution. So what I'm going to show you today is how to graph these by hand to solve them at first. When you do this on your own, you are also welcome to use Desmos, and I'll show you that as we go as well. So solve each system by graphing. Since these are lines, we graph them the normal way we do in slope-intercept form. For this, I'm going to use the blue for this top line here. My top line, my y-intercept is -4, so I make a point at -4 on my y-axis. My slope is 1/2, so I go up 1 and right 2 to get to the next point on my graph. I can also go down 1 and left 2 to extend my graph the other way. Once I have as many points as will fit on that line, draw as straight as a line as you can, which mine looks a little questionable, but you get the idea. I graph this other one in pink. Y-intercept this time is 3. My slope is -5/4, so it's telling me to go down 5 and right 4. I only have room to do that once. I don't have room to go in the opposite direction. Connect those the best I can. So my two lines do intersect. They intersect in exactly one point. That point is right here. The x-coordinate of that point is 4. The y-coordinate of that point is -2. So I don't need you to tell me the words one solution. I just need you to tell me the ordered pair for where they cross, which for this one is 4, -2. Let's keep going. Graph this first. Let me use green for it. -3 is my y-intercept. My slope is down 1, right 4. So down 1, right 4. I can also go up 1, left 4 in the other direction. That's as many as I have room for. So carefully connect the best we can. Now let's do the other line. I'm going to use orange for this one. +3 is my y-intercept, so +3 on the y-axis. Slope is -1/4, so down 1, right 4, or up 1, left 4. Once I have made as many points as will fit, I connect. These are never going to cross. These are parallel lines. So what we say about that, since they will never cross, they have no points in common, we just say no solution. No need to write an ordered pair, just say no solution. Last ones. Y-intercept this time is -2 for this first equation. Slope is -1/3, so down 1 and right 3, or up 1 and left 3. Connect with a line. And then this last equation, y-intercept is +1. My slope is 2/3, which is telling me to go up 2 and right 3. Or I can go down 2 and left 3. It does look like these lines are going to intersect. They definitely do. The point of intersection is -3 for the x-coordinate, -1 for the y-coordinate. So my solution is the ordered pair -3, -1. And I'm going to fix that because I kind of crossed out my negative sign there. -3, -1. There we go. You can also do these in Desmos, which is what I would recommend if you don't have graph paper handy. And if when you go do this for your homework, this is perfectly fine too. The way we do this in Desmos is we literally just type in exactly what we see. Each equation gets its own line. So I'm going to do this last one we just looked at here with the blue and the purple. I'm going to type in my equation, y equals -1 over 3. It's the divided by sign to get the over, x minus 2. Make sure the equation looks exactly like what you have written there. And then I want to graph my other line too, so don't get rid of that one. Click underneath and start typing in the next space. Y equals 2 over 3x plus 1. A really snazzy thing about Desmos is if you click on the point where they intersect, right here it'll tell you that solution, that ordered pair, -3, -1. So you're welcome to use Desmos for these too. That is it for today for graphing to solve systems of equations. Have a wonderful day.